All right, thank you for coming to my talk. This is the Python Datamodel, when and how to write objects. I updated the date, but I didn't update the actual day. This is a redo of yesterday's. Here's a basic outline. We're going to basically cover how Python in general supports both the functional and the object-oriented model, get into the nuts and bolts of both. And so the fool doth think he is wise, but the wise man knows himself to be a fool. A lot of very important people have contributed to the conversation on this, and I want to approach the same subject in all humility. I'm sometimes told I can be condescending. That means I sometimes talk down to people. So we're told to write fewer objects. Who's seen Jack Diedrich's Stop Writing Classes, PyCon 2012? Jack has seen his talk. Great. Basically, the main idea is don't write empty classes or classes where the usage is like an instantiation and a method call. Unnecessary indirection is an ongoing waste of developer time. And then Armin Ranescher wrote a blog post in response to this, telling us to write more classes. And his main idea is layered design for core code can be reused by others. Otherwise, good but monolithic code is a lost opportunity for code reuse. So we have the best of both worlds. We support both functional and object-oriented programming. The ideas from structured programming we can apply in Python. We don't have any go-to to worry about. We can write functions with single entry and exit points. We have map, filter, and reduce both conceptually and literally in the functions and keywords. And we also treat functions as first-class citizens in Python. They are first-class objects. You can pass them pass them two functions as variables and pass them around. On the object-oriented side, we support inheritance, where subtype is a form of a supertype. Composition, where type has a constellation of functionality. Encapsulation, private versus public, where hopefully mature programmers know not to touch the methods that start with underscores. Polymorphism, subtypes provide functions called by the parents, and the idea is a solid. So do we want static typing, limited inheritance, all of these things? Do we want Haskell? I would submit to you that no, we don't actually want Haskell. What we want is to work with mature programmers who make reasonable decisions about design and use. And I'll also submit to you that there's a continuum of programmers. On the one end, we have consumer coders and those who use Python to make their jobs easier. At the other end, we have core programmers, who write for the Python standard library and frameworks that we all use, like Pandas, NumPy, SciPy, Flask, and Django. And we have users in between who maybe have their feet in both worlds. So let's get into the nuts and bolts of functional programming with Python. We can use map and filter in Python 2. Map and filter in Python 2 both create lists. So filter here will create a list, and then that list will be passed to map and thrown away as the map then creates a list. A list comprehension in both Python 2 and 3 creates a list in memory. And if we need it, because we need a list to stick around in memory, then that makes perfect sense. We can also use map and filter to create a data pipeline. In Python 2, it's imap and ifilter, and that becomes map and filter in Python 3. And we also have generator expressions. And both of these create a data pipeline. And both of these are semantically the exact same thing. So when we write functions, I would highly recommend we use named functions instead of lambdas. When we write a named function, we have a function that knows its own name. It knows what module it's in. It has a doc. If we've followed best practices, give it a doc string. And then we call help on that function. We get a very readable and, if our docstring is helpful docstring. So we also want to be able to sometimes bind data to functionality. One of the first things I'd like to cover that does that is the partial functions. We have the tool in functools partial. And this example is from the documentation on that. We bind base2 as an argument to int, and with that argument bound to int, that resulting function, if we pass it a string of ones and zeros, it will always process that as a base2 and return the expected result. We can do a similar thing with closures. The inner function binds data in the local scope of the outer function, and that bound data, the pointer to that bound data, is immutable. If that data structure is immutable, then that data structure won't change, and what the variable points to will not change. If it's mutable, then of course the data structure itself could change. All right, so quick vocab. Who's familiar with Dunder? Who is not? Okay, Dunder means the double underscore, and typically implies both a preceding and a ending double underscore. So, for example, a Dunder dict contains all the instance attributes in an object. So let's get kind of a preview on the object-oriented model. When we have an iterator, like an iterator that we create with a generator expression or this imap and ifilter, what we really have is an object that has a next and an iter method. And so that generator expression and imap and ifilter both return an object that has these two methods on it. So generators are a convenient way to implement the iterator protocol. So when we write this function, we get an object that does these two things. So this is a generator, and before we saw a generator expression. Objects, so Python provides us with ways of interacting with objects, and we have ways of implementing those forms of interaction with what we call magic methods, or in the Python documentation refers to as special method names. They usually begin and end with a double underscore. Len calls object.len, bool calls object.non0 in Python 2, and it falls back to len, and similarly in Python 3, and so on. And I thought it was interesting to note that there is a Dunder del and a Dunder comp, and we should avoid those. Most people find it hard to understand the exact semantics of what del does, and comp is deprecated and not available in Python 3. So when we write a function or a class, one of the first things we should do is write a docstring. When we write a docstring, that object gets a Dunder doc attribute. And so this is always highly recommended when you're writing a function or a class. We have other class attributes that we can create in class definitions. In our class definition, these attributes get assigned to the class Dunder dict. And so these will be single points of reference for all instances. My own personal recommendation is not to use class attributes as default instance attributes, but some people like to do that. I would rather assign those with the Dunder init. I would also submit to you that one of the first functions you should write for your objects are Dunder repers. If we call the help on repr, we see that for most object types in Python, not the base object type, but most other object types, lists, dicts, sets, frozen sets, and things in the collections module, for most object types, the evaluation of the repr of the object should give you an equivalent object. And so that's going to be important later. Here's an example. The datetime object, when we call datetime.now, we get a datetime object. And this is the repr echoed on the command line. This is the actual repr. This is the repr being printed. This is the actual repr. And this is what we get when we evaluate the repr. When we evaluate the repr, we get an equivalent object. So if you eval the built-in objects repr, you'll get a syntax error. And that's because angle brackets and the rest of this are not legal Python. So we should write our own reprs. This is an example of what this hypothetical object, the way it might look when echoed on the command line. My_obj of foo, comma, bar equals bar. And so we initialize, we have a repr, and this is one way of creating a string that represents the state of this object and creating an equivalent object. So we also got a docstring because we wrote a docstring. And so if you recall from the help on repr, to test this, we need to know what an object is equal to. So next thing I would recommend you write is n equals if it makes sense for your object. So this is going to be our test. We decide that we have an attribute foo and an attribute bar, and so if an object has those attributes, and those are the same as another object's attributes, then they're essentially the same object for our purposes. Then the Datamodel docs tells us that when we define Dunder equals, we should also define not equals, so the operators will behave as expected. So let's define a not equals. When we define a not equals, we should use the Python language double equals test for equality, not self.dunder equals. There's a proof for that on Stack Overflow, or you can pause YouTube if you happen to watch on YouTube. Okay, so let's go back to this. We are one method away from being able to sort this. If we wanted to sort these objects, and sometimes that's pretty useful. So let's create a less than method, and then that in combination with the total ordering decorator provides us with a class that has all of those attributes. And so to make this extensible, I've also made this an abstract base class by declaring the meta class ABC meta and given it slots so that subclasses of this can use slots if they choose to. We can't instantiate an abstract base class. The point of an abstract base class is to define basically a template for subclasses and to provide the reuse for the functions that are so intended. All we need to do, as the help says, we have an abstract method order, or actually it's a property. That's probably improved in Python 3. So all we have to do is write a property. We can give it an init so that we have that foo attribute. And then we can create some of these objects, and we can pass them to sorted, and we won't get an error. But we have no way of visually seeing that we don't get an error. So let's write a repr for that so we can see that we don't get an error. And then we can sort of visually inspect here and see that we are sorting the way we've intended to. So how could this be useful? How could we use this this orderable superclass and get some more code reuse out of something else? Maybe we could customize a named tuples sort order. So we'll create a named tuple from the collections module, and then we'll subclass that named tuple and orderable. Orderable first, then named tuple, because we're going to use orderables comparisons for sorting. And all we need to do is define property, give it slots because named tuple requires slots. It requires slots in order to not have a Dunder dict. And then we can sort instances of our named tuple. And when we call vars on the named tuple, it accesses the Dunder dict, which is a property as well. If we look at the source for the named tuple, the Dunder dict is a property. And so this is a trade-off of space for time. And we don't keep around a Dunder dict. Dunder dicts or dicts in Python take up a bit more space than a named tuple, and that's probably one of the reasons you would want to use a named tuple. Okay, so this explains exactly what a named tuple is. With a named tuple, we get a new method. These are just a couple of the things that we get with a named tuple that I thought we should call out. We get a repr. It's a nicely formatted representation of that object. And again, we get that property, the ordered dict for a dict that's created on the fly as we need it. Okay, so we've used property a little bit. We've seen a class decorator. So there's also other method decorators. And so let's cover decorator syntax. The top two functions are not just semantically identical, they are completely equivalent in Python. The top definition is syntactic sugar for the use of a decorator. The second one, we repeat order 3 times. In the first one, we only give the name of the function once. And so I think that's pretty nice. Also, since property is wrapping order, I think it's pretty nice that it comes first instead of at the end of the function definition. So they are equivalent. The below from named tuple, we had to do it like this because we were using a different name for that property. So properties provide a programmatic way to access what is semantically an attribute of your data. They are a trade-off of time for space. We're a little short of time, so I'm going to move forward. Class methods and static methods. So at the top, we have a normal method. We take self as an implicit first argument. Class method takes the class as an implicit first argument. And these are typically used as alternative constructors. My favorite example is dict.fromKeys, which creates a dict. It's another way of creating a dict instead of the usual way. And it will take whatever iterable that you give it and by default give you none, or you can provide a different default. Static methods are just convenient functions that you want to stick onto your object. They aren't a function of the instance or the class, but they're very useful to have around. So if you want to use string.translate, it's very nice to have something that will create a translation table really right there without having to import it from the string module. And that's what string.maketrans does in Python 3. Okay, so we have other ways of interfacing with Python. That's the context manager, and everybody should know this is the way we want to open files in Python, right? So what is this actually doing? When we instantiate open to give us a file object, when we call open, that instantiates a file object, but that's not actually part of the context manager. We're invoking the context manager when we use it with the keyword with. And then what we assign to the variable name with as is not necessarily that object. It's whatever is returned by Dunder enter. So a natural use of opening a file might be to read the file. Then we implicitly, when we leave the code block, we will, no matter what happens, call Dunder exit, which in our case will the file object case we'll call file.close. And this context manager, the exit returns false, which will re-raise any errors. And so we could probably create an abstract base class based on this code. But for a better example, I'd see Raymond Hettinger's PyCon 2015 talk, Beyond PEP 8. We could also create a context manager with a function. And this would essentially wrap the open and guarantee that we close the file no matter what. The enter will take us up to the yield. The f will be returned by enter, and then we will get whatever errors are raised. We can handle those, and in this case, since we're not handling them, all errors will get re-raised. And that's just a demo of that code. So, kind of to go back to Jack's original talk, I would submit to you that we have two possible cases of a useful versus a useless. I would submit to you that the top class is fairly useless. You could do this, and then you could use mydict everywhere. But I don't think that's very wise. Yeah, you would have to go back to this code every time you're debugging and check to see what have they added to mydict. Have they implemented a Dunder missing for the dict? Then am I accessing that with the subscript notation, or am I using .git? And is that why I'm not having the expected behavior? I would submit to you that subclassing exceptions is a good idea. You only want to catch the exceptions that you are prepared to handle. If you're not prepared to handle an exception, it's better to fail early. So I'm going to take a deep breath. These are all the things that we have covered so far. So when do we write objects? We're always writing objects in Python. I would recommend writing custom classes. That depends on your need for reuse. Consumer code is written in a procedural to functional style. Core dependencies are written in more of an object-oriented style, typically supported with functions. Larger code bases will get more benefit from code reuse that object-oriented code provides. I would recommend you use indirection when necessary for correctness. A useful empty class is maybe a subclassed exception, and other types of empty classes, not so much. Any questions?